In this video, we're going to talk about real numbers as opposed to imaginary numbers, which is something we ran across in Algebra 2. In the real number system, there are different types of numbers, and you've seen this chart a couple of times where we have something called the natural numbers. Your natural numbers are your counting numbers, 1, 2, 3, 4, 5. Within the natural numbers, or outside of the natural numbers, I should say, are something called the whole numbers. The whole numbers, which include the natural numbers, they actually start at 0, but they're all positive. Outside of that come the integers. The integers were your positive and negative whole numbers. All of these numbers fall under something called the rational numbers. The rational numbers include the integers, whole numbers, and natural numbers, but they also include repeating or terminating decimals. For example, 1/2 is called a terminating decimal. The reason it's called terminating is because there is a number after the 5, but it's a 0, so we don't write it. 1/3 is the example of a repeating number. It's 0.3333333 forever. All of these numbers are called real numbers. There's another type of real number, and it's called the irrational number. The irrational numbers are your non-repeating, non-terminating decimals. I like to call them ugly decimals. For example, the square root of 3, if you plug that in your calculator, gives you a decimal that does not repeat and does not end. Or the square root of 5. Or pi. Usually you use 3.14 for pi, but it turns out the number is a lot longer than that. The cubed root of 2. All irrational numbers. The properties of real numbers. We have 3 properties of real numbers, and honestly, only one of the 3 do you ever remember its name. But the other 2 are concepts that you should understand. The commutative property is the one that says it does not matter in what order you add 2 numbers. They're the same answer. So you know that 2 plus 3 is the same as 3 plus 2. Well, it turns out that is also true for multiplication. It doesn't matter what order you multiply in. These 2 answers are the same. The associative property, I like to call that the move the parentheses property. It says that A plus the quantity B plus C, order of operations says do parentheses first, is the same as if you move the parentheses and do A plus B first and then add it to C. It's the same for multiplication. You could multiply B and C first and then multiply A, or you can change that and multiply A and B first and then multiply by C. You'll get the same answer. This is important. This pops up all the time in mathematics. It behooves us sometimes to change the order in which we're multiplying things in order to simplify a problem. So keep that one in the back of your head. The distributive property, that's the one everybody knows and loves. It says that A times the quantity B plus C is AB plus AC. However, what people sometimes forget is that it doesn't matter if there's a number to the left of the parentheses or to the right. As long as it's being multiplied, it can be distributed. So very quickly, I'm going to use the distributive property here. When you distribute 2 times the quantity, x plus 3, you multiply the 2 times the x, and then you add that to the 2 times the 3, which is why we get the answer 2x plus 6. For the second one, you would probably recognize this by using something called FOIL, if you learned FOIL. FOIL is just an acronym for how we go about multiplying 2 binomials. First, you multiply the outside numbers. First, the first number from each binomial. Then this would be the outside numbers. And then this would be the inside numbers. and then these would be the last two numbers. So the answer is really just ax plus ay plus bx plus by, and there's nothing you can do with it because none of the terms are like terms, so you can't combine any of them. Now let's talk about the properties of negatives. These are all properties you know, but they are ones that tend to pop up very often in mathematics. So you know if you multiply a negative times a positive, you get a negative. If you multiply two negatives together, it becomes a positive. You should also know that multiplying a negative times a positive, like negative a times b, is the same answer as positive a times negative b, which is just negative ab. If you multiply negative a times negative b, you're multiplying two negatives, so it becomes positive. If you have a negative on the outside of parentheses, that's like saying there's a negative 1 there. So you distribute that negative 1, and it makes these both negative. Remember that a subtraction sign is the same thing as saying plus a negative. But we traditionally write it like this. If I instead make what's inside the parentheses a minus b, and I'm multiplying it by a negative, I would get negative a plus b, because I'm multiplying two negatives together. So let's use the properties of negatives. Let x, y, and z be real numbers. So negative times the quantity x plus z should just give you a negative x and a negative z. Again, if you write it like this, that is also acceptable. Traditionally, we write it like this. In part B, negative times the quantity x plus y minus z is going to be a negative x, a negative y, and a positive z. So really all it does is change all the signs. We will work a lot this year with properties of fractions. And again, these are all ones you've seen before. When you multiply two fractions together, you multiply the numerators, you multiply the denominators. You don't cross-multiply, nor do you say cross-multiply. The phrase cross-multiply has to do with two fractions that are already equal to each other. Dividing fractions is actually the same as multiplying the first fraction by the reciprocal of the second fraction. So division of fractions really is a multiplication problem. But you first have to find the reciprocal of the second fraction. In order to add two fractions together, they have to have a common denominator. And subtract, by the way. If they have a common denominator, then you just add or subtract the numerators and put that answer over the denominator. But what if they don't have a common denominator? Like a over b plus c over d. Well, the common denominator would then be bd. We'll talk about least common denominator in a few minutes. The first fraction needs a d, so you would have a times d, plus the second fraction needs a b, so you would have c times b, or b times c, whichever order you want to write it in. We can simplify fractions. I should write this correctly. AC over BC. The C's cancel, and you're left with A over B. So whenever you have the common factor in the numerator and denominator, they cancel each other. And if A over B equals C over D, now you can cross multiply. Then AD has to equal BC. In example 3, I realize you could actually just plug this into your graphing calculator. You would do 5 over 36 plus 7 over 120. It would give you a decimal. But then if you press Math, Enter, Enter on the graphing calculator, it'll change it back into a fraction with the least common denominator for you. The problem we run into is what happens if these fractions have variables in it. So the way we find the least common denominator, we start with each denominator and we break it down using a factor tree. I like to break things down by dividing by 2, but you could start with 6 and 6. I'm going to start with 2 and 18. 18 breaks down into 2 and 9, and 9 breaks down into 3 and 3. So 2 squared times 3 squared is the prime factorization of 36. For 120, I'm going to do 2 times 60, which is 2 times 30, which is 2 times 15, which is 3 times 5. So 120 breaks down into 2 cubed times 3 times 5. The least common denominator is all the factors you see. So we see a 2, a 3, and a 5. And then each of those factors, you pick the largest exponent. Well, one of them has a 2 squared, one of them has a 2 cubed. Cubed is the larger exponent. One of the breakdowns has a 3 squared, and the other one has a 3 to the first. Square is the largest exponent. And only one of the breakdowns has a 5, so 5 to the first is what you would be left with. So the least common denominator is 2 cubed times 3 squared times 5, which happens to be 360. So I want my denominator to both of these fractions to be 360, which means I have to multiply the first fraction by 10 over 10. The second fraction I have to multiply by 3 over 3. So I'm going to get 50 over 360 plus 21 over 360, and now I can add them, and the answer is 71 over 360. The last thing that I will talk about in this particular video is the real number line. We need to know where numbers fall on the number line. Remember that the way the number line works is when you go to the right, the numbers are getting bigger. And when you go to the left, they're actually getting smaller. Think about it like money. You go in the left direction, you got negative numbers, and you don't want to get more and more negative. So you need to know where to put numbers like the square root of 2. Well, how would I figure out where to put that on the number line? Well, maybe changing it into a decimal might help me out. The square root of 2 is approximately 1.41 something. Well, that means that it would probably be about here. Not quite halfway between 1 and 2. What if I asked you to plot negative 3.5? Well, negative 3.5 should be between negative 3 and negative 4. How about if I asked you to plot 1/4? Well, 1/4 is 0.25. So maybe 0.25 is about here. So now, if I said to, I want to remind you a little bit that like negative 1 is greater than negative 4. And the reason negative 1 is greater than negative 4 is because it's further to the right on the number line. You all know that 3 is less than 5. That's an easy one. But working with negative numbers can sometimes be confusing. So remember that the smaller the negative number, the bigger it actually is.